Greetings and welcome, friends. We're here. We're going over 8.4 homework. We've been talking about like proportionality and stuff. And here's question 7. It says determine whether Km is parallel to Jn. And one of the things we realized was the triangle proportionality theorem said that if we have parallel a segment parallel to one side of the triangle, then it proportionally divides the other two sides. That's not what we're doing here. We're using its converse, and we're going to see if these are in fact proportional to one another. Then we could conclude the parallelness of those segments. So let's see what I got. So I'm going to say 24 is to 15, question mark, is that equal to, is that proportional to 18 is to 10? And let's see, so 24 and 15, both of those are divisible by 3. 3 goes into 24 8 times and into 15 5 times. And 18 and 10 are both divisible by 2, and that's 9/5. That is not true, therefore they are not parallel. Right? Agreed? Concur? All right, I got a thumbs up. Awesome. I got 3 thumbs up. One person can't even do that. Let's see. All right, here we go. This one's going to scare me. Draw a segment with the given length. We're going to try to make my segment like 3 feet long or something. We'll pretend that's my segment. All right? And construct a point that divides the segment in the given ratio. So let me, so the first thing we do here is I draw an arbitrary acute angle like so. All right, something like. Right? And what I'm going to do, I want a 1-to-4 ratio, so I'm going to actually draw, I should have pre-prepped my ellipse tool. Oh, it's still pretty good. I'm going to throw that right at that intersection, and I pick some radial length. All right, whatever I like. Right there sounds good to me. So I'm going to do that, and then I'll move it up here, and then again do that, and like that. And like that. Let's see, how many do I have so far? Looks like I've got 4. Okay, so what I'm now going to do is connect this endpoint to this endpoint. Now, right now, these were arbitrary lengths. This was an arbitrary angle, right? So completely just rando. And so I'm gonna draw this like so. Right? Affirmative? Affirmative. All right, so now let's go back to our ellipse tool, and I'm going to, like so, pick another length. I'm going to try to pick one smaller than the one I was just at. And, yeah, somewhat random. I don't want it larger than the length of that green side, though, obviously. And I'm just going to duplicate this arc radius like so. Arc, A-R-C, not like Ark of the Covenant. Or Noah. All right. And now, oh, shoot. I needed to carry this. Oh, guys, I did that wrong. You know why? I need to carry these arcs all the way down. There we go. Bring it around town. All right. I needed it to intersect this other line. My bad. There was 2 intersections I needed from it, and I only was thinking about one. All right. So now, with where that intersects, that line, so purple-yellow intersections, I'm going to resize my compass, but not arbitrarily. I'm going to resize it so that it intersects purple-green. All right, something like that. You feeling it? The only purple-green intersection right here. Yeah. Let's see. Oh, that's not a working color. What color haven't I not? Dark blue. All right, so there's an intersection, and now I'm moving this to the next purple-yellow intersection, and I'm intersecting purple with blue. Move it to this one, and what this is doing is duplicating angles. All right, I'm cloning an angle, and the angle that I'm cloning it to was the yellow-green angle. So let's draw some more green lines for us, shall we? Actually, you'll end up seeing, because as long as I don't rotate this, I'll be able to just pass it through like so. So from this intersection, which is proportional, passing through the intersection of those two arcs, I've now constructed a parallel green line. Completely arbitrary. Yeah. And so I've duplicated this angle. That means this, and this are congruent. Therefore, by corresponding angles theorem, these are all parallel. And then by three parallel lines theorem, all of these are proportionally divided according to these, which was the one set length that was given to us. And because these are all congruent to each other, because, right, those orange arcs were all equiradial to one another, therefore, these new intersections are going to be congruent to one another. So this and this and this segment has been divided into a ratio of 1 to 4. All right, so kind of a weird construction, but I think it looks really cool with the colors. No. But speaking of three parallel lines theorem, in exercises 17 and 18, you'll find the length of the indicated line segment. So I've got 10 here, I've got 8 there, I've got 12. These lines are parallel by corresponding angles converse. These two lines are parallel by corresponding angles converse. And then the first and the third line are parallel by, like, transitivity, essentially, right? Right? You with me, Aiden, on your laptop? Aiden M? Yeah? Yeah. Let's call SU length X, and I would say X is to 10 as 12 is to 8. I'll reduce that 12 over 8, although you don't have to. That's 3/2, and then multiply both sides by 10, or cross multiply. I know some of you guys are big fans of the cross multiplication. Represent. You guys put, like, cross multiplication on your fantasy football team. No? 15. No? And there are lots of ways you could have set up this original proportion, but they all should have concluded with the same amount. Now, did I actually answer the question? Yeah, don't squeak the chair if you can. SU, yeah, I did. So I'll use their name for it. SU equals 15. So, all right, let's keep cruising. We got a test today. There's my slider. It hides so well. Oh, I love this. So angle bisector intersects the opposite side proportionally was the idea, right? Yes, sir. This length right here, the whole length across was 16. This portion was Q. Q plus whatever this was would have added to 16. So what's another way I could describe this distance right here? 16 minus Q. These are not congruent to each other, so this wasn't the midpoint of that segment, but they are proportional with respect to the other sides of the triangles. It would be the midpoint if this happened to be not just an angle bisector, but if it was a perpendicular bisector, which would have occurred if those two measures were the same. So yeah, it is possible, but in most cases it won't be. So let's see. So 16 minus Q is to 28 as what is to what now? Oh, I did this side. Opposite is to, right, adjacent as, yeah, Q over 36. So yeah, the setup, right. And then once we get it in a proportion, then we could just hand this off. We could outsource this problem to an algebra student, and they'd be like, I got this. And then you'd be like, you're welcome. No. Come on, the algebra you guys are experts at. Let's see, 28Q. 36 times 16. I'm reaching for my calculator. 576, yeah, thank you. Minus 36Q. Make sure you distribute. I don't know if you guys saw that, but when I did the cross multiplication, this entire numerator, this is a vinculum, friends, and yeah, that's like in parentheses. A vinculum is a type of grouping symbol, so be careful. Gots to distribute. And then, yeah, you guys see where it's going from here. Add 36Q for... All right. I'm just waiting to get to the last problem now. Right, you guys see where this is going. What's that? 64? Did I do that right? And then 9. Yeah, q equals 9. You like it? Actually, like, the q and the 9 are so similar, it's just like a q is a 9 with a tail on it. It's true. If you think about it. Question on the math or a question about q's having tails? No? Do you have a question on the math? How can I help? Okay. yeah, that was just a 9 with a tail. All right, here we go. I like this. Now, this problem technically could have shown up in 8.1, I think. If you look at it, this little triangle, all right, is similar to this medium triangle, is similar to this grande triangle, because, right, all these right angles are going to result in parallel lines because they're all perpendicular to the same line. And then by corresponding angles theorem, all of these angles are the same. And then by angle, right, angle, all three of those triangles are now going to be similar to each other. You also could have, actually no, we kind of have to use the triangles, don't we? Yeah. The three parallel lines theorem would have applied to like this dimension, right, or this dimension, but yeah. So I'm going to say 1.5 is to 2 as x is to who? Oh! Right. So check it out. 2 is the entire hypotenuse. The entire hypotenuse, that's the slip up right there, is the 5 plus 2. So that's 7. Cross multiply, you'd get 2x equals 7 plus 3.5, 10.5. Divide both sides by 2, I get x equals 5.25. But that's not the only question, my friends. I'm looking for y. So let's say 1.5 is to 2 again, as y is to who? With the save. All right, so I'll get 2y equals 15, y equals 7.5 when I divide both sides. All right, thanks for watching, Internet friends. Have a great day.